Lesson 2.2 is all about functions. In this lesson, we'll take a look at relations between variables and determining whether or not they are functions. We'll look at function notation, focus on domain, and model real-world situations. The definition of a function, we would say a function denoted as kind of like a lowercase cursive f from a set A to a set B is the relation that assigns an element x in set A to exactly one element in set B. The first element set A, would be known as the domain or your input values, and set B, if that's what you're assigning the values to, is your range or your output values. The graph at the right says this function relates time of day to the temperature. So notice the domain, the set of inputs is 1 through 6, and those stand for times in the afternoon, 1 p.m. to 6 p.m. So these are your x values, your input values. Your y values would be the corresponding temperature. So x is your input and y is your output. Notice that each time only has one corresponding temperature value. That makes the representation of time to temperature a function. Other ways to represent ordered pairs, whether or not they are a function, are shown below, just with a list. Notice on the left it says this does represent a function. Look at all of our input values. We would say that the domain are all of those numbers. X can equal -2, -1, 0, 2, and 4. There's no repetition, which means each x value matches to exactly one y value. However, on the right, it says this set of ordered pairs does not. So let's take a look now at our input values. Notice for our domain here, we list them the same way. X could equal -2, -1, 0, 2, but then 0 repeats itself. So because of that repetition, that means each input has more than one corresponding output. So because of that repetition, this is not a function. Typically, when we write equations of lines, we're normally used to writing in the form y equals mx plus b, where x is our input and y is our output. Using what's known as function notation replaces y with f of x. Kind of like when we did our projectile motion problems and we had h of t in parentheses. This is just another way to represent output. We could have g of x, we could have h of x. As long as our input is one thing, then the g of that value or the h of that value or the f of that value would represent your output. It says let f of x equal this quadratic function, -x squared plus 4x plus 1. Find each function value. So if it says f of 2, what that means is we're plugging in an input of 2. I'll say let x equal 2. So then f of 2 will equal -2 squared plus 4 times 2 plus 1. Now we have to be careful on this. Remember our order of operations? Since the 2 is not, the negative is not in parentheses with the 2, our order of operations would have us do that exponent first. 2 squared is 4, and that negative would technically make it -4. And then we have plus 4 times 2 is 8. And then we have plus 1. So that would mean -4 plus 8 plus 1 has a value of 5. F of 2 has an output of 5. If you're asked to input another letter, well then we just plug that letter in place as well. So now it says f of m. So now we're just going to say let x equal m, which sounds kind of weird because m is going to be in our final answer. So we'd say f of m equals negative, and instead of x squared, it's going to be m squared. Plus 4 times x, that becomes 4 times m, and then plus 1. Now what makes this unique is really that's all we can do. We don't know the value of m, so therefore that is our function value. Now the last one requires a little bit more work, f of x plus 2. And now what we're going to do is every time we see x, we'll plug in x plus 2 in its place. So now I'm going to give myself a little bit more room here. F of x plus 2, whoops, I got to write that out correctly. Hang on here. Let's try that again. F of x plus 2. Now anytime I see x in the equation, we have to plug in x plus 2 in its place. That gives me negative x plus 2, and then squared, plus 4 times x plus 2, plus 1. Now, we've talked about this before. Anytime you have a parenthesis being squared, we have to FOIL that. And if you do, you get negative on the outside, x plus 2 times x plus 2 would be x squared plus 4x plus 4 when we're done. Distribute this 4 in, 4x plus 8, and then plus 1. Now, to eliminate the parentheses, we have to actually distribute that negative in. We'll make all three terms negative. Negative x squared minus 4x minus 4. And then we have the plus 4x, and then 8 and 1 is 9. Hoofda. Now combine like terms. We've got negative 4x and positive 4x. They cancel out, leaving us with negative x squared, and then negative 4 plus 9 is plus 5. So f of x plus 2 has an output of negative x squared plus 5. And that's as far as you could go. So notice, you guys, if you have a number for your input, then you'll have a number for your output. If you have a variable for your input in that parenthesis, then that same variable is in your output answer. Now tomorrow we'll focus on specifically looking at domain of functions.